Don't do math. Don't do math. Okay, let's go back. Let's pause here. With a right triangle, how can I check if it's a right triangle? I don't have angles. What about the hypotenuse? I square both of their measures and add them. And they must be congruent to the hypotenuse squared. What's that formula called again? Oh. So Pythagorean theorem tells us that a squared plus is equal to c squared. Can I only use it for this purpose? For right triangles? What can I use it for?
Used to prove that it's not a triangle.
I can use to prove that it's not a right triangle. Oh, finally we're getting it. So how do I show that it's obtuse? How do I show if it's obtuse? How do I do that? Oh my God, the spring break packet. Okay, let's take a second. And watch this video. Miss Epps, please get the lights, please. What's going on here? The area of the other two sides are adding up to the hypotenuse. Kevin, what were you going to say? What he said? What he said? What he said? The sides squared equal the hypotenuse. What does this remind you of? What does this remind you of? What does this remind you of? Yesterday's work. Okay, but yesterday, what were we working with? What about those squares? Yes, but what do we find for those squares? Their areas. So the area in here, the area that the water is in, if I add these two smaller squares, then the water fills up that square. What I want you to think about is, what if I made this triangle an acute triangle? It is no longer a right triangle. What if it was acute? And these two were full. If I turned it around, how much water would go into the large square? Take 10 seconds. Don't answer. 10 seconds and think about it. Now take 30 seconds and talk about it. Not to me, to each other. What would happen if this was acute and I turned it around? How much water would go in C? 30 seconds. Go. After you're talking. Hi, I'm Edith. Hi, I'm Diana. What do you think would happen to the water? I don't know. No, you said
I told you, I said that.
Okay, 5, 4, 3, 2, 1. All right. So what do you all think would happen? Zion. So all the water would go into that and it would get full, just like it did? Okay, so Zion is telling me that if this was a cube and these two were full, if I flipped it around, I would continue to fill that one up. Anyone think any different? Are they? by more? The size would change since it's a cube. Where would there be more water? Can you explain that to me? I'm a little confused. The big square? So would it fill the big square or not fill the big square? It won't fill it? It will overfill it. So there would be water left over. Okay. Anyone think any different? Kevin? Barrington? I saw another hand somewhere on this side of the room. You're in the same group. We can't disagree. Oh, we all disagree. You all disagree? Okay, give it to me. Give it to me.
I said less because since it's in the cube is less than a right triangle when it's still a little square.
Okay, so we're talking about less than or greater than. We're talking about what? Inequalities. How can I write that? Right here I have a square, and another square. How can I write your thoughts into an inequality? A squared plus b squared. Let's talk about a cube. Right? That's what we started with. And a cube triangle. A squared plus b squared, these two together, Arlene is telling me that it would overfill. So she's telling me that these two are greater than this one. Terry Ann is telling me that it wouldn't fill it up all the way. So she's telling me that these two together are less than this one. Let's take a vote. Who thinks that these two together, if it's a cube, is greater than this? So then C would overfill. Okay? Who thinks it's less?
How would it overfill?
Okay. So A squared plus B squared is greater than C squared. So now, what would happen if this was obtuse and these were filled? Once I turned it around, is C squared going to be almost full or overfilling? Almost full. So you're telling me then that C squared is? So A squared plus B squared is? Okay. Okay. 1. I woke up at 4 o'clock in the morning today. I don't remember the answer to this. I'm exhausted. I know, right? Because everyone knows this. I know that. I'm not too tired for that. What I want you to do now is, there are bags with squares on your desk. Listen before you all start. Listen up. In those bags, there are 8 squares. Each square has a different letter. It started with D. D through K. So there's capital H and lowercase I, because capital I and capital H look alike. Yes, mine do. I don't know about yours, but mine do. They are little. So what you're going to do now is to do what we've been working with the past couple of days. You're putting those triangles together to form, those squares together to form a triangle. Okay, I know half of you are not listening to me, and I don't like repeating directions. So, how many do I need to make a triangle in the middle? 3. Not all easy. I know, really. Okay. Up here. 5, 4, 3, 2. Delilah. 1. Okay. In front of you, there's an activity sheet. The first column has different combinations of letters. Those letters will match your squares. You're putting those 3 squares together and then filling out this activity sheet. It's going to ask you for the size of the side and then the area of the square. You're then going to tell me, based on your hypothesis or prediction, whether that is an acute triangle inside here, whether it's obtuse, or whether it's right. The that will tell me if it's a, okay, go. You all have 10 minutes before we check in. Make sure you have 8 squares.
That's what it's saying? Is she saying that this one is easy? I said, is she saying that this one is easy? Because I don't do all this.